Hello friends, welcome you all to the next lecture of the JCE Connect online series of lectures. We are into module 4 and we are solving examples on moment of inertia. Let us continue with the examples. So again, as per my routine, I have taken a different example. What I am trying to do is, in minimum possible number of examples, I am trying to cover maximum possible variety so that you can practice the similar examples. Okay, so let's start with today's example. In today's example, what we have is, we have to determine the moment of inertia of a plane lamina about the x-axis. X-axis is given. Okay, so these are the examples which will become very easy in your final exam, because directly axis is given. There is no need of applying any theorem and all. Directly about that x axis which is given to you all, we have to find the moment of inertia. Okay, and as per the given data, only we have to find the moment of inertia about x axis itself. Okay, there is no requirement of finding moment of inertia about y axis. So the example becomes easy. Similar example can also come in your centroid problem. So such examples, if you practice for centroid, further extending them into moment of inertia is quite simple. So the important things to be considered here in this example are the given dimensions of the figure. We have a rectangle, we have a triangle at the bottom, and the circular section which is there is a cutout section. You will be able to see the color difference. The rectangle and the triangle are shaded with grey, whereas circle is not shaded, as that circular portion is a cutout section. I think the cutout section problems we have solved in center of gravity examples. Okay, so in that, what we used to do, we used to take the area as negative. Same principle we have to follow here, nothing changes. Okay, the area of the circle has to be taken as negative. So the most important things here to be discussed will be the areas of all the figures. The rectangle width is 50 plus 50, that is 100, and the depth or the height is 75 plus 75, which is 150. Then for the triangle, the base is 100 and the height is 120, and the circle has a radius of 25, which is a cutout section, which has to be taken as minus. Next, we have to determine the moment of inertia about the given axis, which is x, which is marked. Okay, so we have to locate y1, y2, y3 with respect to this given x axis. Okay, this is one more point which is important. So directly let's get to the table. So what you have to do is, first you can see the video, then second you have to draw the figure, then come to the table. Okay, so we'll have the figure in front of you as well as the table on the screen, so that reference will be easy. So let us take the first element, which is the rectangle. Area of the rectangle is 150 by 100. Now y, that is the centroidal distance of the rectangle from the x axis, which is given as 75. It is directly, you can take it because directly 75 is mentioned there if you see into the figure. Then ay square, then igx. Okay, only we want here igx to be calculated. There is no need of calculation of igy, because moment of inertia is asked only about x axis, which is given in the figure. So the formula which I am using for rectangle igx is bd cube by 12. Okay, so these formulas are independent of any distances and all. These are only dependent on the figure, the shape of the figure. Okay, bd cube by 12. Then next, triangle. Area of the triangle will be half, base is 100, and the height is 120. Sorry, by mistake that one is misprinted, please excuse me. The area is half, base is 100, height is 120. Then y is the centroidal distance of the triangle from the x axis, which will be 1/3 of the height of the triangle, which is 1/3 of 120. We get it as 40. Now The important thing here is this minus sign. Okay guys, please remember, as the triangle is below your axis, okay, the triangle is below the axis, the y component here is negative, okay, the y component here is negative, you should be careful about this. So we will have y value as minus 40 because it goes in the below quadrants, okay, y axis we are considering here as negative. So your y value is minus 40. Now if you make a mistake in this calculation and if you forget to take minus sign, okay, all the example will go wrong. Then ay square calculation, then igx. Now one more important point here in the igx calculation for the triangle is the axis which we are referring is xx. It itself forms the base of the triangle. Okay, so we have a direct formula for the center ig value for with base as the axis. Okay, so when we have discussed the formula, this has been told. For triangle we have two set of formulas. One is with respect to CG axis, one is with respect to base. Now here that we can use directly because here our xx axis is itself the base of the triangle. Okay, see the figure, it will be clear. So which formula I will use? Yes, I will use the formula bh cube by 36. Okay, I will use the formula bh cube by 36. So mark this also. This also is a very important point. Then comes the circle. As I have told that circle is a cutout section, area of the circle will be pi r square with a negative sign. Then y, which is the centroidal distance of the circle from the axis under consideration, is 75. Then further a y square calculation will come. As a is negative, it comes with a negative sign. Then igx for the circle is pi r raised to 4 divided by 4. Okay, pi r raised to 4 divided by 4, and this moment of inertia carries a negative sign. Why moment of inertia carries a negative sign? Because that much of mass is removed. Okay, that much of mass does not exist in the system, right? So we cannot add that to the igx summation. That much of mass is removed from the system, and mass is directly connected with moment of inertia, which I have explained you in your first introduction chapter of moment of inertia. So here we get the answer of igx as minus pi into r raised to 4 divided by 4. Then we will get the summation of igx. So what we have discussed here, the table we have discussed here, that is a1, y1, a2, y2, a3, y3. Then we have calculated ay square values for all the three components. Then we went for the calculation of igx. Here we are calculating only igx because the moment of inertia is asked about xx axis, which is given in the figure. Okay, so firstly for rectangle we have used the formula bd cube by 12. Then for the triangle we have used the formula such that as the base of the triangle is itself the reference axis, we have used the formula bh cube by 36. Then for the circle our formula is pi r raised to 4 by 4, and it comes with a negative sign as it is a cutout section and that much of the mass we are removing from the system. Then further we take summation of a, summation of ay square, and summation of summation of igx. Okay, so all the three summations we take, then our formula ixx is equal to summation of igx plus summation of ay square. Substituting the values, we get the moment of inertia for the given figure as 1.155 into 10 raised to 8 mm raised to 4 about given xx axis. Okay, so this moment of inertia is not about the centroidal axis of the figure, but here we are finding the moment of inertia of the figure with respect to the given axis as per the question. So don't apply here parallel axis theorem and do some stupid things. What is asked we have found out. So if such examples come in the exam, bindas, you should go and attempt them, because these are very straightforward examples and hardly in 10 to 12 minutes you can cover this entire example if you have practiced it properly. So let's move ahead with the next example. Now this example again is on the similar principle as the previous example, okay, but the shapes are changed. Okay, the shapes are changed, but the principle is same. Compute the moment of inertia of the figure, of the area shown in the figure about AB axis. Okay, means here in this case they have given AB axis, whereas in the previous case it was XX. It's just the nomenclature. So horizontal axis is given, about which we have to find the moment of inertia of the figure. Now the important things to be noted down here is, this example has been asked repeatedly in your final exam, and it has been asked in both the categories, that is also to find centroid as well as to find moment of inertia. So you can take this example itself, and also you can find the centroid about both x and y axis, taking the reference axis wherever you want as a practice. So now currently let us concentrate on obtaining the moment of inertia of this figure. So we find that the figure consists of a triangle, a semicircle and a circle which is a cutout. Okay, so you have to observe it properly. Triangle has a height of 80 and the base of the triangle will be nothing but the diameter. Okay, so here diameter of that semicircle is there. Carefully if you see, the diameter of the semicircle is available, which is 30 units or 30 mm. Hence the base of the triangle, the radius is available, that is 30 mm. Hence the base of the triangle is twice the radius, therefore it will be 60 mm. So base of the semicircle and base of the triangle here are the same. So let's go ahead with the table, draw the figure properly, mark all the dimensions. Okay, so now the same table which we have to fill. First component in the table is a triangle. Area of the triangle is half, base into height, half into base is 60 and height is 80. How we got the base? The base of the triangle is itself the base of the semicircle, which is of radius 30 units. Hence the base of the semicircle is nothing but the diameter of the semicircle. Therefore it will be 30 plus 30, that is 60, and that 60 itself is the base of the triangle. Hence we get the area of the triangle as half into base, which is 60, into height, which is 80 units. Then y. Okay, so y1, y2, y3, all the three values have to be located with respect to which axis? Yes, with respect to your given AB axis. Okay, no need to take any axis in this example, because already they have given an axis, and about that axis itself we want to find the moment of inertia. Therefore the y1 value will be equal to h by 3, that is 80 by 3. Then we will get next value a into y and a into y square. So now again similarly as in the previous example, for the triangle the base itself is the reference axis. So we can use the formula for IGX of a triangle with respect to the base, which is BD cube by 36. And substituting, we get the IGX value for the triangle as 853.33 into 10 raised to 3 mm raised to 4. Then next comes the semicircle. Okay, next comes the semicircle. Area of the semicircle is pi r square by 2. Then y, okay, y is 4 into r by 3 pi, and here minus sign has to be put. I have not put the minus sign purposely, as while writing you should have that much of awareness, because the semicircle is below the x-axis. Okay, the semicircle is on the below side of the x-axis. Y values have to be negative. So while writing, take that y component of the semicircle with a negative sign, that is y2 will be minus 12.732. Okay, this minus is not because it is a cutout, this minus is because that the semicircle is below the x-axis, hence its y component is negative. Then find a into y bar, and the formula for your igx of a semicircle, okay, is 0.11 into r raised to 4. See, I have explained, when the semicircle is in first quadrant and first, second quadrant and third, fourth quadrant, this formula which we have applied has to be used, okay, for finding igx. If you have gone through the previous videos and made the tables ready, this becomes very easy now. Then third component is a circle. In area itself as well as in moment of inertia, we have to take a negative sign because it is cut out. So with a negative sign, when we start, the area of the circle is pi r square. Okay, so here, okay, so the area formula is pi r square, that by 2 while copy pasting from the top has come. Okay, take the right formula. Now here the important thing is y becomes 0 because the center of the circle is lying on the given axis itself. There is no gap between the center of the circle and the axis, hence y is 0. As y is 0, the next two terms also become 0. Directly we come to which term? That is igx. igx here comes with a negative sign as it is a cutout section, and we use the formula pi r raised to 4 by 4. Hence now all our columns are ready. Take the required summations, and hence how can we obtain ixx value? Ixx is equal to summation of igx plus summation of ay square. So substituting the values, we get the moment of inertia about the given AB axis as 2.753 into 10 raised to 6 mm raised to 4. Okay, so the small correction you make it while solving. One is what? y2 is not taken with the negative value in the formula. Take the negative value. Third is a3, which is the area of the circle, is pi r square. So that divide by 2, you ignore it. So this is how we find the moment of inertia about the given axis. Now in both the cases which I solved, the given axis was horizontal one. Okay. Similarly, you can get a problem where the given axis is vertical and we have to find the moment of inertia of the given figure about that vertical axis. So in that case, what all changes? The first area columns remains as it is. Then instead of y1, y2, y3 and so on, we will be calculating x1, x2, x3. Next column will become ax. Next column is ax square, and the last column we'll have is igy instead of igx. Okay, and in that case we will be required to find iyy. Okay, that is the moment of inertia about the vertical axis. Iyy will need to find in those cases. So here ixx is nothing but iab, because the given axis is named as AB. I have taken the regular notation. So while writing your final answer, you can write it IAB is equal to whatever is the answer, because the given axis is AB in this example. So let's take up one more example. Now we'll find that here we have an arrow shaped object where in between a rectangle is cut out, and in this case we have to obtain the radius of gyration of the shaded area about an axis normal to the symmetrical axis. Okay, about an axis normal to the symmetrical axis. So firstly, up to where you can do is up to iyy you can find. Now see, the difference in this example is in previous examples we had a horizontal reference, whereas here we have a vertical reference first. Then second, we have been asked to find the radius of gyration of the shaded area about an axis normal to the symmetrical axis. Okay, so what do you mean by axis normal to the symmetrical axis? When we look at the figure is symmetrical about which axis? X or y? X axis. Okay, the figure is symmetrical about x axis. So axis normal to that is perpendicular axis. So in the given example, the axis 2, 2 which is marked will be our reference. So what we will have to find? We have to find I value of the figure about which axis? The vertical axis, that is, we'll find I y y. Okay, I y y, I bar y y or I bar 2 2. Previous cases, previous both examples, what we found I x x, okay, or I a b. Both horizontal references were there. Now we have a vertical reference in this figure. Then further, what is asked again? Radius of gyration. So once you get I y y, you can easily find the radius of gyration using the formula k is equal to square root of I y y divided by capital A. So I am troubling you all a bit with this example. I have kept the table half. I have mentioned the components. Okay, the table is to be filled. What all you have to find is given above. Okay, x, ax square and igy. Okay, so rectangle formula will be, you have to use it now as per the axis given. Remember, for rectangle always the side perpendicular to the axis will be the cube. Okay, you have two rectangles here to deal with. So properly fill this table and obtain the values of I 2 2. Then going further, obtain the value of I bar y and use this I bar y value to find radius of gyration. Okay, because we want radius of gyration with respect to axis which is normal to the symmetrical axis. The symmetrical axis is horizontal, hence our normal axis will be vertical. So we are finding first the I value here with respect to your I 2 2. Then use the parallel axis theorem to get the value of I y or I bar y. Then use that I bar y value to find radius of gyration. So if you are able to do this example properly, okay, you can be confident of yourself that you will pass, sorry, not only pass, but you will do well in the examination. Okay, so hope once your internal gets over, you will properly solve these examples. Thank you.